Hi everyone, you're welcome back to my channel. This is App Terminus and you're welcome back. So today we'll just be understanding what happens on the internet. So when you browse, what do you think is happening? So let's jump right into it and I will show you what is really happening and you actually have understand, because most times we just browse. Okay, for example, now I said I want to go to cnn.com. Let me see if this is going to go through. Okay, let me use another. Let's use okay, it worked. So look at it now. So what we are, okay, look at this. There's even a redirection, because if we take a close look at let me see if I can increase CNN here. Let's see if I can increase this. So here we have what we got here was the URL. We have a redirect. We have edition.cnn.com. So that's not the major bone of contention for today. Let me do example.org. Now this takes us to this website and I will show us what is happening in the background. Which other channel? Okay, let me look at which closed channel can I look at? Okay, let me look at Jumia.com. I don't know if Jumia is still working here. I just want to use familiar websites so we can talk about it. Okay, now we have Jumia.com, so we'll be taking a look at Jumia.com, example.com. So basically what we want to look at is what is really happening here. So all of the material we'll be using in this video, I have them on my GitHub and I'm going to attach them to the video. It's going to be in the description, so I will attach it to the description. So just check the description. You have the three of them. So I sectioned it into three. I have a DNS tutorial, which is understanding the domain name system, and I have a part that talks about lab, because we are going to practically examine and understand these things practically. And lastly, we are going to be doing taking a look at the recursive resolvers and all of that. So we're going to talk about that. We are going to understand it. So, and let's not forget that basically everything we are doing comes from this where's this textbook? It's coming from this textbook. Yeah, so we use this textbook as an outline, but we are not taking all of the content verbatim. So I've added a lot of stuff that will make you understand better, because here it was basically just, let me just say, it was paraphrased. It was paraphrased here. So this is the section that we had. This is chapter 3 parts. This should be part 3. So now let's come back here. Now the first thing is, whenever you put in your domain name, which is www.jumia.com.ng, directly you get the web page. But a lot of things happen beneath the hood, under the hood. So we are going to expose most of those things, because on the internet. So let's start with this. Let's come back to, no, don't need this now. Come in just a minute. Okay, we are starting from here. So when we talk about DNS, let me expand this a bit so that we can see it. More. So when we talk about DNS simply means domain name system. So it's simply the same thing as it's synonymous to phone book of the internet. So definitely what we are trying to say here is just like we have a phone and we have the numbers. Ideally, what you need to call someone is the number, not the name on your phone. So I'm just choosing the scenario of your phone. So majorly, it's just for ease of identifying and then being able to remember. That is why we have name attached to the phone number. That's why you see a lot of people, even when you want to ask a girl out, you ask them, "Can I have your number?" Not "Can I have your name that I can search you with on the internet or call you with?" It will definitely be the number. So now we are going to demystify and break this down too. So on the internet also, to reach out to someone or to get to a domain or get to any resources online that you want to get to, you need IP address. So IP address is synonymous to the phone numbers that we say we have, while domain name is synonymous to the name that we had or tagged to a number when we are saving it on our phone. So, and remember I talked about AI. So if there's a need and you don't understand anything, just copy this, go to your AI, and you can just ask several questions you want to ask. I want you to explain this in details to me, and you can just have this, and whichever way you want to prompt it, that's where we have a prompt engineering. So this is going to further explain it. So I won't be talking much on things that you need explanation on. You can actually just take them to the AI. So now let's just read through this. Then we are going to do the practical aspect of it, and I'm going to show you everything vividly how this communication works. So they said it's often called the phone book of the internet. It translates human-friendly domain names like example.com, which is going to be one of those domain. So when you see things like this, they call them domain name. Like www.example.com is a domain name, which is synonymous to the name we save a number with on our phone book. So they said names like this into machine readable IP addresses, which is this. So now, if on our phone we have a way to save a number and add the name to it, how does the internet do this? Because basically we have the domain name, and when we use the domain name on the browser URL and you hit enter, it takes you directly to the domain name. So how does it go back? So now DNS is a central DNS server, a central phone book where you have all IP address appended to the relative domain name that they are associated with. We are going to talk about that and we're going to look into that. So now they said, how does this generally works? So you can actually read through this, but it's the same representation I have here. So first of all, if a user enters www.com, www.cnn, www.jumia, any website that you know of on the internet, when you enter that particular domain name on your browser and you click enter, so the first thing the browser does is to check your local cache. It checks your local cache. We are using Linux. We don't have a local cache on this Linux, and I'm going to actually demonstrate that. So now, as we are going through this tutorial, I'll be referring back to these pictures, and so that we can have an illustrative pictorial illustration. We can have pictorial illustration. So the first thing your browser will do is to check your local cache, and if your local cache is like your own temporal storage on your own system, that whenever you visit a website, it will store it for you. It will store it there. So it will store the IP address and the domain name. So whenever I want to visit it again, I will not go the long route of going into the internet, going to the major phone book, which is the DNS servers, and grabbing the IP address and bringing it back, because that's the IP address that our browser will use to get to the websites we are going to. So in that case, if your local cache has it, it returns the IP address. Just follow along with me. We are going to explain this practically. So remember, we are doing this practically. So if your local cache actually has the domain name and the IP address, it returns the IP address to your browser. Then your browser will now use the IP address to visit the websites you want to visit. So, but if that's not the case, your browser proceeds to query your ISP. Your ISP is your internet service provider. So like I'm in Nigeria now, internet service providers like MTN, Airtel, Globalcom, those are our ISP. I have a router at home that I'm using, and it belongs to MTN. So that means if I'm visiting any website that my system does not have a cache for, I will be directed to query the resolver on my ISP. That's MTN. So now once I get to the resolver, the resolver will now start doing its magic. The resolver is like a police, traffic police. What it does is it gets the request, look at it, send it to the root server. I'm going to explain this in detail. Send it to the root server. Then the root server makes the necessary check and look at, okay, which TLD server should I send this to? It will tell me, then return it back. It will tell it back to the resolver. The resolver, knowing this now, will now take that TLD. Okay, this is the direction the root server asked me to go. Then it will go to the TLD. So when you get to the TLD manages the .com, .org, .net, .shop, .online. So when we get to the TLD will now say, okay, this is the particular name server you should check. This is where I have in my record that this will be saved. It's a structured phone book. It's just like on my phone now. If I'm going to let me say alphabet O, that's an alphabet O. Instead of starting from A, B, C, I can just jump to maybe M, N, O, because I know it's very close to O. You understand? So that is what the TLD is going to tell us. It's going to tell us the particular name server. So this name server is where we have the IP address mapped to the domain where it is saved, and that will be returned back to the browser. So I hope that helps. So I wouldn't want us to waste much time on that. So now, the diagram above shows the user initiated the request, just like I've explained. The local cache, I've just talked about it. Hierarchical DNS resolution. So the DNS resolution starts from the recursive resolver, final connection to the web server, then the website being displayed to the user. So now, having known this, these are common DNS records, and I'm going to discuss these two now. So the first one is a record, and I'm going to actually show them practically. We are going to see it. We have the A record that is maps a domain to an IPv4. So when we are talking about an IPv4 IP address, let me show us something. Here, real quick. So now, let's say I grab www.jumia.com, or let me just take it from Jumia. Copy. I come to my Kali. If I do ping that particular IP address, okay, let me make this bigger. So if I should click on this and say this. So this is supposed to resolve this. This will resolve. Okay, it has already been resolved. So all of these things happen very fast on the internet, but we are going to actually dig into it. But I want this to connect so that we can know that this actually connects. Okay. So this pinging shows that I sent a request to this. I sent a request to this and it's responding. So now, if you take a look at it now, it is from the byte that's from the website coming back to me. This is the IP address that they identify it with. Sure, you understand? So this is an IPv4 IP address. IPv4 IP address, and I think later in this series of lessons, we are going to be talking about, and I think we've talked about it before, IPv4, IPv6. I don't want to digress too much. I just want to focus on whatever this lesson is going to be talking about. So this is a sample of how IPv4 IP looks like, and if you want to take a look at what IPv6 looks like, let me check my I will check my private IP address and show you the IPv4 there. Remember, we talk about IP address show. So if we take a look at this, this is our IPv4 here. So the reason why IPv4 was created, because we envisage that the number of devices that will be online is going to actually exceed the capacity that IPv6 can. It's like IPv6 has a particular, I've forgotten the number, you can actually check that out online. Total number of devices that it can cover that can use it at the same time simultaneously online. So because of the fear, because when this was created, nobody knew that we are going to have a widespread of devices on the internet and all of that. So, but now that we are tending to approach the fullest number that can be accommodated on IPv4, then we are moving to IPv6. That's the reason why we have IPv6, and this is how it looks like. Yeah, this is how it looks like. So, you see, we have it HiNet 6. So that's all for that. I just want to clear hair on that. We are good. Let's exit this and let's pump this right back up. Let's pump this right back up. So we're done with this, and let's go back here. So CNAME, we are going to talk about this. Look at, so actually we're going to talk about this. So the major stuff we're looking at today is the DNS servers, and these are the major one that does the function of taking the domain name, converting it to IP address, and returning it back to us. It's not actually converting it, it's just checking to look at its phone book, pick out the IP address, and send the IP address back to the browser. Then the browser uses that to go to where it wants to go to. And the major tools that we are going to be using today are, we look at an NS lookup, dig, and WhoIs. WhoIs gives you publicly available information about an IP about. You can use an IP address and it can be a domain name, while dig is a more advanced DNS tool. So I'm going to show us how to use that. We are going to demonstrate that. So before we go forward, I want us to take a look at this. This is a diagram of how this works. So if I should enter www.example into, this is my client's device, which is my browser. If I should enter it here, first of all, it's going to go to recursive resolver. Then the recursive resolver goes to the root name server, take it back to the recursive. The recursive then take it to the TLD server. From the TLD server, is going to grab the necessary information about where it should go next. Then from there, recursive server takes it back and take us to authoritative name server. That is where we are going to get the IP address, which is saved under the A record. So once it gets it, it returns it back to the recursive resolver. Then recursive resolver now send it back to the to our browser. Then the browser then uses it to get to where it is going to, because it's only with IP addresses that devices are identified online, and it's only with IP address that you can get to whichever resources you want to go to. So that's closed. Then let's jump into the lab part of it and start fingering things and start looking at, okay, what can we check out. So basically, I'm going to be talking about this in Linux, but note that this is whichever one that I can actually show in Windows, I'm going to show. But remember that it's the same principle that this is built upon. So for the simulation, the first thing we're going to do is, so this first part we're just talking about, we don't need this, Linux sudo resolve. Okay, you don't need to flush cache here, because on this Linux we don't really have cache. And I noticed that on this Linux, what I'm using on this Linux is a result.config. Yeah, so I might make a correction to this, but just be observant of what I do on my system. So open a browser and type example.com. So let's come to this particular point here. Let's do, we have example.com here, but let me create another one. We have example. It can be whichever domain name that you want to try out with. So even before, let's do www.jumia.com.ng. Okay, so before clicking on enter, now let's take a look at our local. If you try this on we are not going to see this here on Linux, because if you choose, okay, now let's come to our Linux and do this. Copy this, take it to, remember I'm doing Jumia, so you have to be very conscious. I'll do that's Ctrl+Shift+V to paste. Then instead of doing this, first of all, let's look at the content of this particular file. If you do this, look at what we have here. Remember we spoke about 127.0.0.1 as our local host. So that's why whenever you want to talk with, if softwares within your system want to talk to each other, that is what they use. And basically that is what it is. But this particular folder here, this particular file here, I will quickly do something now. This particular file, that will be at the end of this something, because I can use this file to map another IP address to a wrong domain. Now, instead of taking you to CNN, I can map that CNN takes you to example.com or take you to any other website. So I can do it from here. So we're going to talk about that. So what this wanted us to know is we want to check if example.com or whichever domain that we want to go to has been mapped here before, but this has not been mapped. Look at what, by checking this, it has not been mapped. So if I come back to, let's say I paste this now, it means grep. It means grep. Look for example.com inside host. And if you notice, we don't have it here. So I will show us something. So let me grow this a bit, and let's increase the size of this font of this. So if I do this, it's not going to give me anything. But let's take a look at, okay, what do we think we have here? I know we have test here. So instead of using example.com, let me use test. So I'll come down here. So to just show you that this is what this is doing, let's say TST. Now look at it. We're able to grab this out, which is the first line. So if I'm looking for local, if I should put in localhost now, it's going to give me this line. But if I give it localhost and this local domain, it's just going to give me this line. So I think we've talked about grep. I've taught it. If you haven't seen this, you can check my previous video, and you are going to be brought to speed on this. So let's just, for the last one, let's just do local host. So if I'm using combination of words, it's best I put them in quotes so that the space will not be influencing it. So I can do local domain. So if I should put this in now, look at it, and it mapped it that this is what you are looking for, and it's on this line, and that is everything it has here. So that is what this one is really talking about. So now it wants us to just check. So the next thing we need to do now is Wireshark comes inbuilt with it comes as utility. No, it comes out of the box with your Kali here. So I can actually just say, let's say Wireshark. Take this out. So while this is still loading, let me do this. So capture this, open Wireshark and filter for DNS packets. We're going to do that. We will now see the DNS query in action. So now they want us. So that means after setting this up, we can trigger. So when we trigger, we are going to see the details of what is happening. Then we start doing some in-depth analysis. We'll do some in-depth analysis, and at the end of it all, we now come back to see how hackers could use. How hackers can manipulate this particular results and use it to do malicious stuff. So here, let me come back and say, okay, we have Wireshark now. I want it to be on the Ethernet. So now I can filter for DNS by just typing DNS. So I click DNS. So let's go back to, notice that we don't have anything here. Then I will go back to this browser. Then I'm going to punch this in. Beautiful. So this is great. What I'm going to do now is come back here. Let's stop this, and let's look at. Let's go back to look at what we have here. And if you take a closer look at what we have here, because all of these are DNS. And what do you notice here? There's two things I'm noticing here: the source IP address and the destination IP address. And if you look at it, the only difference we have between them is the last octet, which is, this is the first octet, this is the second, this is the third, this is the last octet, and this is the last octet here. So one of these IP address is the IP address of this system, this local system. We are going to look at that now. Okay, let's quickly take a look at that. Okay, so if I do IP ADR show, this is my IP address here. And the second one you are seeing, which is which is .2, which is 192.168.110.2. So on your own system, this private IP address is going to be totally different. I don't know what it's going to be. So, but it's going to follow the same pattern. You are going to have your IP address and your gateway. This gateway is we talked about it the last time, is my way to the internet, which is going to, when I say gateway, the gateway is going to be on your router. Your gateway, your gateway is your router. So that means this IP address is this gateway is the IP address of my router, because my router will not be the one to route my connection out of this environment. So by that doing, we can come here if you want to see that. So you can just do IP. It's going to be IP route, IP route show, which is going to verify your default gateway. Plug that in. Okay, let me make this a little bit darker so that you can see. Is it action? Is it edit? Is it view? Sorry, I'm trying to IP address log this. Actions. Oh, I'm just trying to. Okay, reference. So I want to make it a little bit darker. Application application transparency. Let me see if this is going to work. Is apply. Okay. Makes it darker so that we can see it. Then I've applied this. Then let's say okay, and let's make this bigger so there won't be transparency and you can actually see. So now, if we take a good look at it, this is our gateway. It means our default route is via this gateway, which is through my router here. So that's what I want to show. And taking a keen look at it, this is my source IP address, which is SRC, the source IP address. So let's go back to our Wireshark. And if you take a good look at our Wireshark now, the first thing we had was a DNS protocol. That's what I want to point out. This is a DNS protocol, which is a domain name server. And if you take a good look at it, let's come down here. If you look at the domain name system query, so who is this being sent to? Let's look at this query. So Jumia this.com type A class in. So this is what is sending out to go look for. This is what is heading out to go check. That okay, I need the type A record. I know the type A record and DNS record for this particular domain, which is www.jumia.com.ng. You can use any domain name, whichever one you feel like using. So this is what I want us to see here. Let me see where, possibly if I can see where it was returned to, where we get the response. This is query. All of this is this. I want to see creative, where IP address was sent back. Let's see where IP address was sent back. DNS this a Jumia. Okay, this is the response. Okay, and look at it. It's here under answer. Now, if you take a close look at it, we have. Now, if you look at the answer that we have here. Okay, before I expand this, this is very interesting. Okay, now it's telling us we have Jumia.com type. This is the CNAME class. In CNAME, we have www.jumia.com.ng.cdn. This CDN we are going to talk about is CDN content delivery network. So this is the layer of security for all websites to safeguard them against DDoS and all of that. So if I'm going to a website, now instead of hitting the website directly or hitting the server hosting the website directly, I hit the DNS. The DNS now stands as an intermediary that now tends to look at, okay, is this traffic going to this guy? Is this safe? So we have a lot of series of security on that. But that is not the bone of contention for this class. So for this class, what we're looking at is, actually, we are not getting the IP address of Jumia directly. We are getting that of the Cloudflare, which when we approach with the name Jumia is going to take us to wherever we are going to. So let's just leave it at that, and we are going to talk more about that later. So I just hope that we understand this. And the reason why we have more than one IP address here, we have like 2 IP addresses here. We have 162.15, and what can we do with this? Okay, now let me see if I can. Let's see if we can do something with this. Let me do call hyphen capital H. Okay, this, but I'm not going to be using that. Let's see this IP address here. 162.159.141.127. So now our host is not going to be example.com. This one is going to be this is going to be jumia.com.ng. So this should take us to permanently moved. Okay, because the header is not really full, it might not actually take us directly to okay. Or let me try if it is HTTPS. Let's try if it is HTTPS. Here, connection error. Okay, because SSL and TLS alert handshake is not. So some security measures are in place for this. I might not be able to do it directly with this, but this will work with because this is CDN. I've recommended this is where I'm going to. Okay, let me try this. Let's try this. If this doesn't work, let's just move on, and I'm going to show us what works. There are some few security measures on ground here, but this does not affect what I really want us to get. Okay, this is not, because if we take a look at, let me clear this. Let's say we take a look at, let's say we do, let's say, what can we do here? Let's say okay, I did not even copy the IP address. Let's copy this IP address, Control Shift C, and then I can do ping this. No, I'm not pinging, so it's reachable. I just want to do who is this. So this should give me publicly available information about the IP address, and if we take a look at it, we're going to see that it's Cloudflare. This is Cloudflare. So this is a level of security that is being placed on website these days. We don't used to have this was not in place because far back, but this is in place now because of attacks on websites and all of that. So for this now, for you to directly hit those websites, first of all, you have to go through the intermediary. That's why we have Cloudflare. Look at it, we have Cloudflare here. So that's what it indicates here. Let me just take this. Let me just do clear. So now we've been able to do this. So before we go that fast, let's quickly let's do. Okay, I don't have the IP address for that, so we'll be doing that later. So now I've been able to show you on Wireshark what was happening and what really happened. So what really happened first was our IP was the traffic from my laptop private IP address to the gateway, saying I need to know the IP address AAA. That's an A type record for www.jumia.com.ng. So that is what we have here. And if we datagram, this is the query. This is what it's looking for. So give me type A class name. This is the name of the domain name, but I need the IP address. That is what it's saying. So who is going to respond to me? So and we got our response not too far off. So you notice that two things happened here. Two requests was made. Give me the IPv6. I told you that A record is IPv4, then AAA record is IPv6. So IPv6 record 2 was actually requested for, but this is what we got. So we got for IPv6 also, and if you take a look at it, it's just similar to what I showed you initially. The address is 2A06. You understand? It's not really that convenient or very easy to actually work with, like the IP address we have. Like we have 196.2.this, so that is one thing about IPv6. So I've been able to show you on Wireshark to show you, because what we just did with Wireshark is to capture the raw packets sent over the wire, which is our traffic. So whenever you see within that 1 second before I stopped the recording of this traffic, over 3,400. It was just like 2 seconds, 1 second. Over 3,402 packets have been sent. So a lot of things happen on the internet very fast. So we might not actually know, but a lot of people just enjoy the internet and what the shit, we just leave it that way. So I think I'm done with this. Let me go to the next. So after triggering that, press the enter, then simultaneously run this. I've already showed, so I can run. We did for Jumia.com. So let's do NS lookup. Let's just hide this for now. Let's do NS lookup for Jumia. I think www.jumia.com.ng. Now, taking a look at this now, this is telling me about, this is my own server. Okay, I think I'm getting this from my, this is coming from my ISP. They already have it cached. You'll notice that the server that returned this back to me is my gateway, which is my ISP. So he said non-authoritative answer. I got this. Gave me, this is the canonical name, which is the CNAME. Then the IP address. Remember that I got this similar IP address too from the request. Yeah, if we go back to this response, so 162.195.162.195.14127, the same thing. So this gives us more IP address. I told you you can have multiple IP address pointing to the CDN, and this is done because of redundancy. In case if one server is down, another server will be able to pick it up. So it's for load balancing and it reduces redundancy. So looking at this now, we've been able to check that. Let's just exhaust this and we can jump in right into looking at the logic. So dig. Okay, let me just do up, then I can just dig. So if we take a look at dig also, it's giving us the same similar, the CNAME is the same thing as what we have here, and the IP address is the same thing. The two IP addresses that we got from this particular part is the same thing that we got here. So this IP address is pointing to the Cloudflare. Cloudflare is another service, like I spoke about, that provides security for websites. So we can call them WAF, web application firewall. Yeah, because it provides security. So it tends to determine what will be allowed to pass through and what will not be allowed. So that's a thing to consider also. However, using both of them is similar. So you see now we have type A. Remember our Wireshark 2 was making reference to type A. This is your type A. Type A. This is not show our type. This is not show the AAA. So, but I think from dig, clear. From dig, I can look for the AA. So just for you to have the AAA here and push it in, and you're going to get the AAA, which is the IPv6 which is the IPv6, what do we call it? IPv6 IP address for this CDN IP address. Because to every IPv6 you have equivalent IPv. So I said to every IPv4 you have equivalent IPv6 that matches up with it. So yeah, so here now we done. Just a minute. So okay, and let's look at where we stopped. Where I stopped at the time. Okay, now we've been able to use dig to look at the information, and likewise we have used dig and NS lookup, and they give us almost the same thing. So we have the non-authoritative answer, which is when you take a good look at it here. Where is it? Okay, it's because I'm doing. Let's go back to NS lookup. Okay, we have non-authoritative answer. We have it here, and we did that of dig also. Dig, we're only looking for. So we have the answer section here, which is the non-authoritative also. Okay. So another way to do it is, and we can actually track our. But if we try this now, I'm not sure if it's going to work, and I'm going to show us the reason why. So for this now, we can track how the DNS resolves, so we can track it. So before then, let's just take a look at this, and we'll come back to this authoritative. Okay, root, the breakdown. Okay, we are going to come back to this after we've spoken about where I want us to go now. Observe this, and this. We don't need this. NS lookup. Okay, this is when we'll talk about this. This is name. This is DNS name server from Google. This is Google DNS, and you notice that we have it here. So I'm going to share this material. We are going to have a link to them on the description of this video. So now let's come back to the last part of this. Here now we are going to take each step by step to now see. Now we are going to dismantle those steps and take it one by one, like we are doing it ourselves. So now we are going to approach the recursive. We are going to approach the recursive server. From the recursive server, move to the root server, move to the TLD server, then lastly we go to the authoritative server, which is going to now give us the IP address. So we'll see how the browser or how the resolver does this. So recursive, we talk about it, is like a librarian, and it's almost the same thing as a traffic cop who is doing the direction. Remember I showed us this picture. This is what the recursive server is. So let's come back to this particular part. Okay, recursive resolver do the heavy lifting in DNS resolution. We have accept your request, which is this, fetch the answer, this, catch this. So now let's go to the practical demonstration of how we can work the recursive resolver. So here they are saying we should flush the cache, but to show you that we don't have cache here, let me clear this. We don't have cache on Linux here on this particular system because we are using our default gateway DNS. So if I put this here, instead of having this, let's do statistics. Okay. So if we have cache here, it's supposed to show it. Now let me show you browser to have cache. Let me show you the browser for this our cache. So if you want to check browser for cache, you just go to your browser. If you are on Mozilla Firefox, do about, then colon, you can do networking, so it's going to autocomplete. If you run this, if I come to DNS here, let me increase this. So this is DNS here, DNS. Okay, this is clear cache. These are the cache we already have here. This is what we have here cached, and then if you want to take a look, we have some HTTP HTTP catch, which are those places that we visited, which is Jumia that I visited today, is the CNN where I visited to has been cached. So whenever I'm trying to reach this website again, because I've cached it already, fragment of the information that is needed that my browser needs to go and be checking everything up and down, it will just pick it here. So here, I'm pretty sure the IP address should be by one side, beside it there. Okay, let me see if I can put this in perspective a bit. I do. Okay, this is just showing the protocols. Then DNS lookup. You can do DNS lookup even from here if you want to do any test. If I do example.com, let's do the resolver. Look at it. Okay, let's do for the one we just did the other time. jumia.com.ng. Let's increase this. jumia.com.ng. Let's resolve this. We are still going to get. Now remember, okay, this IP address is going to be for. It should be Cloudflare again. Copy. So to check this, you can actually use WhoIs like we did the other time. WhoIs, then plug in the IP address. So what did we? Okay, now like I said, if we actually had this as cached, we are going to have our statistics here. So what I have as a caching system on my system here, and it's going to be a bomb-proof, a bomb fact to what we've seen before. Let's do cat etc. Then I have what is the name? That's in resolve.config. Okay, resolve.config. So if I'm not, let me check. Let me do ls/ let's do this etc. This. I want to see resolve. Let me see where we have my R. Almost time since like this, you can just pass it into your list and say grep. So this is where ability to use the functions, do test manipulation comes in. So it's resolve I'm looking for. Okay, this is the name and this is what I'm looking for. So I can copy this, come back here. So it's just at least just technically just try some things out. So now if we take a look at this now, okay, let me clear this so that we have it as clean and neat as possible. So let's go back here. So now if you look at it now, our name server, local name server on this Kali is 192. And remember that I showed you this before. Let's take a look at this clear. So let's do IP. Okay, IP routes show. Now this, compare this to this. So this is my name server. It means is my ISP, internet service provider, that is doing my DNS, which is N name server. DNS is doing my how will I say, my configuration for me. Is doing my domain resolution, which is a domain resolution for me. So let's come here. So after doing that, now let's do, okay, we are not capturing traffic now, we've done that before. Okay, now let's do DNS. We've done DNS before, but we want to, no, we've done it before. We've done this before and captured it using Wireshark, the earlier part of this video. How recursive resolver work behind. Okay, now check if cached. So we won't be using the cache. We want to query. We'll be acting like the recursive resolver now. We will query our root. We're going to query our root server. So we will do that. Query this. Okay. Recursive server. Dig. First of all, how do we even do that? We want to query our comment. I want to check. There's a way we query it. Okay, let me see if I can remember. There's a dig cnn.com. Then I can do because it's .com, I can do com dot, no, it's going to be this. No, let's go back here. There's something I'm looking. Let's see if so this is time, something I'm looking at. This what is missing, query this, root says ask.tm. So we want to do that. There is a way. There's a way around that. Please, I'm coming. Dig at this. No. Okay. So that's what I said. For learning, we can just do to query the root server while acting something like the resolver, recursive resolver. Okay, using terminal. Okay, using terminal on Kali. So let's check that out. I saw the command before. I just forgot. I just wanted to show us. We have 13. We have 13. Root server. Okay, this one, you pick any of them. This. And I want us to actually query it and. Okay, for we to get the root this thing, we are going to let's do we do dig CNN dig at okay, this is giving us the name. Okay, now if you look at this now, these guys are using AWS DNS resolver. Okay, but that is not where we want to go. So what we are going to do is the a dot. Okay, let's take a ns lookup for cnn.com. CNN.com, that gives us a lot, but that's not what we're looking for. There's something I want to show us. Coming, let me see if I can get something out of here. This. So what we might do now is to trace. Okay, that will be. I'm trying to look for a particular shortcut, but I'm not seeing it. So what we are going to do now is we are going to visit a particular website and trace how the resolver does this thing. So what we do is let me show you something first. Let's do man dig. We've talked about this command before, so I'll take us down to this is plus st. Okay, trace. So now if you do trace, this option toggles tracing of the delegation part from the root name. Look at it, from the root name servers for the name being looked up. Tracing is disabled by default. When tracing is enabled, dig makes interactive queries to resolve the name being looked up. It follows the referral from the root server showing. Okay, so that is what I really wanted it to do. I wanted to track how this name are being resolved. So if you want to escape this, is just to click on your queue, and I'm out. So let's clear this. Then now we do dig. I'm not using any resolver. Let's do cnn.com. Then you do plus ttrace. So let's do this. Now there's something here now. This trace wouldn't work because my resolve. Okay, it wouldn't work because my router will not permit it to go through. So what I will do, my SSP will not permit it because my SSP actually know where I'm going to. So it will be like, why the need do you want to do this? So all I needed to do now is, let's take this, then ensure that we are using another name server entirely that is different from what my SSP is going to present me. Okay, and before we go, let me show you. If you do who is for 8888888, this is Google. This is let me type it here. This is Google DNS DNS server. So from here, if I should do this, this should show us that it belongs to Google. Look at it, it belongs to Google. So we have for Cloudflare. I think Cloudflare is 1111. We have who is for Cloudflare is 1111. Okay, am I right? This Cloudflare. Assign portable. Okay, this is for Cloudflare. Not Cloudflare. Belongs to Cloudflare. Look at it. Cloudflare DNS resolver project. You see? And so now we're going to use that of Google. 8888, then have a space. So we have dig at 8.8.8.8cnn.com, then trace. I want to see how it's going to resolve it. Like, how will the Google resolver do this thing? Now, if you take a good look at this, let me close this for now. Let's exit here. Let's exit here. Exit. So I want this to be back. Okay, now let's take a closer look at this. So now we want to go to CNN. This is what this is doing. We intend to go to CNN. Our dig went through Google DNS system. So this trace is for us to know how the resolver did his work. How did it go to the root server, come back, go to the TLD, then come back, then go to the authoritative server before we now get the IP address. Now, I don't know, maybe part of some part of what I wrote here. Let's come to this place. The DNS server here. We say the DNS server, the DNS root server. Root server had the first step in DNS resolution. They don't know the IP. It doesn't know the IP address. So what it's going to do is it's going to separate my domain name, the domain name that I want to go to, and the dot, whatever it is. You know, we can have .com, .net, .shop, .online, whatever it is. It's going to separate it, then go back to, okay, you will know that, okay, this is .com. For Jumia, it's going to be .ng or .ng or .com, because .com. Now, if you notice that when I did Jumia.com, it's added .ng to it. So I can use, it's going to identify the .com and identify the .ng. So it's going to now redirect the resolver to say, okay, if you want to go to TLD, go to .com or .ng. You are going to find what you are looking for. That's for the Jumia. So now, but they direct queries to the correct top layer, which is TLD, top layer domain. I talked about this. You can see this too when you check my thing. So they say what the root server does by point, it acts as a traffic cop for DNS queries. It will be the one to tell you where you are supposed to go check for this, and you are going to find it there. So the key point is, so we have 11 logical, this is what I want to point out, we have 11 logical server. And the reason why server is simply a system that have access, that have they have a public IP address that we can reach it online. So when people talk about cloud is the same thing as having a system. I have a system that has been configured in such a way that it has a public IP address that I can use to reach it by itself. For me now, my system, you can't reach me with my public IP address because I'm using an ISP. So the IP address is not registered in my name or in my device name. So anybody that wants to reach me, if you see my IP address, if I show you now, it's the IP address of my ISP because I'm borrowing the IP to use and I'm paying them for it. You understand? That's why when you saw, for you to visit the internet and all of that. So we have 13, and if we come back here to count, here we are going to see that we have 13 here. We have 13 here if you count. So it's from A, B, C, D to M. A, B, C, D to M. So, and if you notice, how you know it is, you see it as root servers. So whenever I said I want to visit CNN, so for me to get the IP address of CNN, this is what happened. First of all, the resolver sends my query, which is going to be resolver from Google, send it to the root. So the root will now tell me where I am supposed to go to. You tell me, is it .com or look at it now. We are doing for CNN.com. So it's now going to say, okay, go to. It will now redirect the resolver to send the query to .com. That .com will be the one to know where CNN is. So if we come down a little bit, this is our. Now you notice that it's only .com that we have here. This is .com. So .com, global top level domain servers. This is the TLD. Now let's come back to this. So the first, all those ones that have root as their prefix, root. This is where they came to. So at this point here, we are here. So I want us to just be able to see this. We are here at this root server name. Then when we comes down, it tells it go to .com. .com comes to this place where we have TLD. That's why we have. That's why. Oh, sorry. That's why we have TLD here. We have TLD global top level domain. Yeah. Afterward, we can scroll down. Afterward, now looking at this, it will now take us to the child zone, authoritative zone, where we are going to get the IP address, and this is name server, which is the example.com name server. So okay, let me correct myself. This is the name server for Google, but for we to get to this name server, these are the processes it's going to follow. So now, once it gets to, this is our name server now, NS. You notice that this is even easy to understand. TLD, we have the root. So we have the root server, we have the TLD, and we have NS, name server. So on this name server, now this is now telling us that the DNS that is in charge of, that has the IP address of CNN.com is AWS. So from here, I can even know that these guys are, no, it doesn't really matter because domain name, you can actually buy it and point it elsewhere. So I won't say what I want to say now. So now, look at this. We have this here. And that takes us to the end of it. Once you get to the name server will now return the AA record. Remember that we talked about the AA record when I showed us the Wireshark AA record, which are the IP address to get to CNN.com. So now, if not for the CDN that we have in front of this, IPs, which is sometimes we are having. Let's even check this. Let's check this if it's going to. Let's see the CDN they are using. Copy. Okay, let's see something they're using. Copy, and let's come to. Let me do this. Let's do who is for this. And see what is going to bring. Is he another CDN? Cyca, this direct, Fastly. Organization is Fastly. This guy too should be So let's see, maybe we can see their website for Fastly. So that's another bit of reason we're doing another research. Let's see Fastly. Look at it, and Fastly is a setup, is a CDN service. Okay, I don't know if you can see this. See, Fastly. So this is how you gather information about this thing. So they are using the CDN that CNN is using is Fastly. It's Fastly Incorporation, an American company based in San Francisco, which describes itself as a cloud computing blah blah blah. But what I want you to take home here is CDN, Content Delivery Network, which is the same thing as they are doing the same function as Cloudflare, which is what we saw behind. Was it example.com? I think Jumia. Cloudflare. So Cloudflare, if you take a look at Cloudflare too, it's a CDN. Where is it? Cloudflare, they offer CDN as part of their services. Okay, let's go there. CDN. I want to just show us where they have the CDN registered on their listing. Build scale. Okay, look at it here. CDN. So it's Content Delivery Network. So we have done that. Let's go back. What we did here was to just look at this IP address. So it means that if this IP address is not directly going to CNN, but I can use it to get to CNN. If I use that IP to get to the CDN and tell it I'm going to CNN, and which was what we did here the other time. Let's try this again. Let's use call this, and I'm going to do I have the IP address? Yes, that's the IP address here. Then just do cnn.com. So call no alternative certificate. Okay, the certificate is the problem here. I know it's because we have other level of security here. That's the reason why. If this is properly formulated, it should take us to, but I'm not going through that now. I'm not going through that now. Let's play. I just want to show us what is going on under the hood. This. So no, we don't need this again. We talked about this. Let's come here. Let's come back to this part. So we talk about AWS as the authoritative name server here. Now, another thing we can vet this by coming to, let me do Control R. This, let's do this. So if I do name lookup for CNN.com. Now, let's take a king CNN canonical name. This is not, let me use dig. If dig is going to give me more. Okay, CNN is showing that we are using Fastly. Using the name server here. No, this is CDN is the Fastly. And then let me check for the name server. Let's use dig to check for CNN.com. But we are not tracing you now. So now look at it now. All the information we have here. DNS is the same thing as what we have here, which is the name server. The name server we are using. This name server here, and these are their respective IP addresses, which is the same thing as what we have here. Sure you understand. So we've been able to validate what is happening behind the scene. So most times when you just say you are going to, if you say you are going to example.com like this, and you are able to see where you are going to immediately, this is what is happening behind the hood. So let's do for Jumia. We did dig at this, then let's come to say jumia.com.ng, and then I have plus trace. So this is still, you see, it's still loading. It's not done yet. It's still loading. Okay, now it's done. Because it seems that this is the first time it's going there. Oh, network failure. yeah, some few servers are going to fail, and we're still able to get results. So I want to see if the TLD is going to be .ng or .com. Look at it here. This is .ng. It took it to .ng. I don't know if you get what is really happening here. It took it to .ng, and these are the name. How will I call it? TLD. This is the name server. This is the root. This is the what do we call? This is the name server. But actually, it's like this one jumps the TLD. We are supposed to, or maybe we just have one TLD here, because this is the root. Then we don't have the TLD and name server straight. Okay, this is the TLD because it's in NG. This is what it's looking for. This is our TLD. But the TLD came in form of NS. We have NS and NSSEC. This is it. Maybe the way this one has been registered. Okay, and NS. Yeah, this is registered. We can actually dig into this more. But this is just to give you an overview of what is happening here. Okay. Lastly, let's now go to clear. I've been able to show you what I want us to know. Clear and the practical part. So I'll be sharing all of this on my GitHub, and you can have access to it. And lastly, let's just take a look at what we have here. So what does this textbook says? So if you want to know the name server for Hackers Rise, almost the same thing as what we have done. Okay. Now we talk about, I've showed you how to use dig a bit, IP addresses, enter this. Okay, let's just do this. Let me copy. Let me just copy this. So dig NS gives us the name server. This gives us the name server. NS means name server. If I want to do let me see, if I want to do for the root, I think it's this dot, and you run this. Let me see what it gave us. Did it give us the roots? Okay, look at it. Give us the root server. This is for us to get the root server. This is how you get the root server. Then if we want to get the TLD server, we just do this. Come here, we look at it. This is .com. This is .com. So we just add com, then full stop in front of it, and we run this. If we come down now, this is our TLD. This is our TLD. And if we know our TLD, we can actually copy our TLD. We can copy our TLD, copy this, and we can do dig paste this, then cnn.com, and what else? That's dig this, give us this, and cnn.com. That's all. We run that. If we run this now, it's giving us the name server. So this is our name server, cnn.authoritative section. So this is just the ability to be able to understand this and break it down. Sincerely, when I did this research is when I fully understand what is happening in the fucking DNS. Sorry for that word, in the DNS. So now the next thing to do is we can just copy one of these and use it to get the IP address for our CNN. So I'll just do dig at. Let's copy one of this. Copy, then paste. Then I will just do cnn.com. So the next thing this is going to give me is going to return the IP address. So if you take a look at it now, we have the IP addresses here. Yeah. So it's like deconstructing and constructing it by ourselves. If you take a look at when we're looking at the top layer domain, we did not get, it only gave us the IP address of the DNS. But now we've been able to get the IP address of cnn.com here. IP address of cnn.com. So, and this IP is not directly the IP address of CNN because we've checked the other time. It's like the CDN, which is a security measure put in place. We can come here and say dig this. No, it's not dig this. Who is? Check this and give us information. Okay, I'll talk about it fastly. I will be able to confirm that fastly is a CDN, which is Content Delivery Network. So we are good. So the last part of it is the attack part of it. So as a penetration tester, or as you can map whatever IP address to any domain name. Now, if I configure this, I can go to this particular place. I can go to, let's do nano. Let me clear so that we can see this clearly. I can do nano/etc/hosts. So if we open this now, look at this now, we have all of this. So I can come down here and I can come down to this part. Let's come down to this class and add whichever IP address we want. So let me just say Abio's IP, DNS abuse. So now let's do this. Let me ping CNN and see the IP address that will be given. So this is the IP address, and I know it's CDN, but notwithstanding. So I'm not sure. Let's see if this is going to actually work. Let's copy this IP address here. Copy. Come here. Paste it. This IP address is for CNN, but I want it to go to. I will now put the domain name as example.com. Example.com. So if anybody tries to visit example.com, you should take them to CNN. That's my aim. So let's just pray that this works. Yes, modified. Okay, I'm unable to modify this now. Ctrl-C to cancel and exit. So Ctrl-N. Now you have to add sudo to it because it's a configuration file. So you need a root privilege to edit it. It's asking for my password. Is my password correct? Okay, now we can do the same damage again. So let's say let's just say DNS abuse. That's like spoofing. So we'll come down here, paste this. Let's just do example.com. So I'll do www. Okay, let's do www.example. I think it's org. So if I do Ctrl+S and Ctrl+X, this is saved now, and you can cut to be sure that it is what you think it is. Let's do hosts. So if we do this now, this is what I just entered here now. We can clear this and let's go back to my browser and do example.org. I need to clear my cache, or let me do this in okay, I can't do incognito. I want to do incognito, but if I can't do incognito, I can just come to settings. Let's go to settings and clear this. Let's do cache. I want to clear my cache. Okay, this is clear history cookies, and this clear it. Then come to my cache settings. Cookie this, save changes. Clear history. I want to clear my cache. clear. I want to clear history, cookies, and everything. Okay, clear. Manage the data. Look how we have CNN here. Manage cookies. Remove all. I'm removing everything. Save changes. Clear now. So I think I've been able to clear everything. Then let's go back. So if I do example.org, okay, I'm adding www.example.com. This is how it's going to see it. So this should take us to CNN. Oh, it's not working. These guys are making this so difficult now. So let me look at the example here, because that's the same thing we are going to do. Dig here, goes to this place, MX. No, this one is just to check your mail server instead of checking just the DNS. So just to check mail server. So changing our DNS. Let's see. Resolver DNS. Okay, we don't need to. We've talked about that. Name server this. What would this do? Let's check what this will do. Let's check what name server. Okay, that was just added to the template, just like what we just did. This was what they added to this etc. If you want to change, like here that we said our cart is we have resolve. We have resolve here. So if I want to change this to, instead of using my ISP, I can just do sudo nano /etc/resolve this, and we are going to just come down here and just say I can quote this so that it becomes a comment, and I can do name server 8.8.8.8 and you just save it, and we save it. So if I save this now, I'll do something now. Let's Control S, Control X. So if I do dig, or let's just say NS lookup for CNN, our own server is now going to be 888 instead of 198-.2, which was our gateway. Now we are using that of Google. So let me leave that and let's change this back. Let's come back here, say this, and I come down here to take this out, then take this one out. So I can do Control S and Control X. So let's go back and just say NS lookup for this, and if you take it, this has changed. Take a good look at this. This has changed from what we have here. So that is it for that. So host. So by default also contain a mapping of this, but you can add other IP addresses. That is what it's talking about. Okay, now you could map bank of this to your local website. To my local website. Okay. Yeah, to my local website. Oh, okay, that was what they actually do here. So because most websites online now have a lot of robust security. So let's do something. Let's do something here. Let's do localhost. To the localhost. Okay, now what is happening is let me check my services. How do we do this again? Apache. I want to check want to quickly check something I've forgotten. Services. Okay. So that's where your AI comes in. I know what I want to do, but I've forgotten the command. So I'll just come back here. Just say how to check on the services online. Okay, I think it's service that I've forgotten. Is it start? I've forgotten the command. So there's a lot to learn, and then that's why it's good to probably when you have these things, you just document them. So when they come around again, you don't forget system D. Let me see what it's going to do. Nope. No, I just want all the services list units. I want all the services. System leads. Okay, is this one I used to use? I've forgotten this one. This is the one I used to use. Come down here, press this here. So now the services that has plus, these services that has plus means they are running. But this one negative, they are not active. So I want to start this. If I start this, I should be able to use I should be able to visit my local server. My local host is supposed to take me to a default Apache web page. So let me just come here. Okay. So what I will do here is to do sudo systemctl. I'm not doing status. Okay, let's do status. Just check Apache 2. Kali. Now, if you take a look at this now, it says Apache server loaded but inactive, which is dead. So let's make it active now. Let's change that. I use Q to escape that, and you can just go back, then come here and say start. If I start this now, let me come back here to check the services again. It should have plus now. Look at it, my Apache has plus now, means it's running. And the same way, likewise, that I can check here and just check the status. If you check the status, it's active now. This is active. It shows that it's running now. So once it's running now, let's go back here and do our local host. If that is not working, okay, is there anything it should do? Let's just do 127.27. Okay, it should be localhost. I've forgotten the port is running on. So let's do localhost. Let's do localhost. So we make it port 80. Make it port 80. What did I do? Okay, now localhost port 80. So this localhost port 80, if I should run let me do, that's localhost port 80, and we can actually do, let's do 127.0.0.1, which is the same thing as localhost. It takes us here. So now I can map this IP address to example.com. So let's come back here. That's what I actually want to do. Sudo nano resolve this. Nope. Sudo nano. Okay. Sudo nano. Okay. Yeah. Here now. So I can just come down here and map 127 to example.org. 127.0.0.1 to so address X. I've done this, so I can come back to, all I needed to do is X from here, clear, then just restart this. I think, I don't know if it's needed, but just to be on the safer side, restart this, then let's go back here and do example.org. Did you visit here the other time? Was it .com that I did .org? example.org. This is supposed to use this. What have I done? Is there anything? Okay, let me check this again. Example.org. This example.org. So this. Okay. Let me put .at at the back, or let's just do HTTP this. Let me restart it. So this is the last part of the something. I just want to demonstrate this place. Catch. Let's clear. Let's clear all of this. Set permission and preference. Okay, no sets. Don't do that for settings. Let's clear the cache, temporary cache. Manage exemptions. Okay, this is nothing here. Manage this. There's nothing here. Cancel. History. Clear history. Clear the histories. Settings. Okay, save settings. So let's come back here, and if it doesn't work here, I don't know why. I'll just take a look at it. Example.org. Okay, now it's working. So now I've been able to successfully map example.com to my local web page on my system. So this can actually be used to just demonstrate how this can be manipulated, and a few settings can be done on your system that is going to give you some wide and wow results. But for today, I know we've learned about DNS, and we now understand what DNS is and how it works. So whenever we visit any website, what happens under the hood now has been revealed to us. So thank you for watching, and then I would really appreciate it if you can smash the like button, subscribe if you are not a subscriber, so that this will help other people that are looking for contents like this. I really appreciate that. Thank you so much for the time. This is really actually exhausting. The research was crazy, but the delivery was superb, and thank you so much, everyone. See you. Peace out.